A strange lava flow within Tanzania exists, an actively erupting mountain which is truly the world's strangest volcano. This volcano erupts low-temperature black lava which has a viscosity so low that it causes it to flow and splash around like water. This lava is highly enriched in rare earth elements, and its red glow only becomes visible once the sun sets. Doinyo Lengai volcano. But even weirder is the fact that these black lava flows generally within 100 hours or less completely change in color, going from black to white. So, why does all of this occur at the fascinating Doinyo Lengai volcano, which is the only volcano in the world to have erupted this unique type of lava in historic time? An unusual composition. The answer involves some chemistry, and the fact that lava Doinyo Lengai erupts falls outside of a traditional classification diagram. At every other of the more than 1,300 active volcanoes on Earth, the lava which erupts has a single dominant component, which the vast majority of the time makes up the majority of its composition by weight. What I am referring to is silica, aka silicon dioxide, which for example comprises 50% by weight of kilauea's lava flows, or 64% of the more viscous lava flows at Mount St. Helens. Lava viscosity. Each increase in the amount of silica creates a lava flow with a higher viscosity, as additional silicon dioxide forms chains which impede lava movement. In contrast, lavas erupted at Tanzania's Doinyo Lengai volcano since 1250 have not had this impediment, containing only 3% by weight silica. As a result, when its lavas erupt, they flow downhill like water at speeds sometimes exceeding 30 miles per hour. These lavas are about half the temperature of basaltic lavas, and contain at least 50% by weight carbonate minerals while also being enriched in sodium and potassium. It is because of this high carbonate composition that Doinyo Lengai's recent lavas are classified as natrocarbonatite. Natrocarbonatite formation. Natrocarbonatite originates when, under very rare circumstances, phonolite composition magma in the crust gets so enriched in alkali elements and carbon dioxide that a threshold is reached. This suddenly causes two different composition liquids to separate from one another in a manner similar to adding water to oil. Since this process also concentrates large quantities of rare earth elements, these then travel with and are deposited wherever natrocarbonatite lava is emplaced. The reason why these natrocarbonatite lavas change in color so rapidly once they erupt relates to unstable minerals it contains being altered to hydrated compounds or being completely transformed into new minerals. By weight, the two most common minerals in a freshly erupted natrocarbonatite lava flow are gregarite and nairite, which have these chemical formulas. Both of these are unstable in the atmosphere, even hypothetically in a very dry desert, due to the water vapor air naturally contains. A change in color. For example, nairite rapidly hydrates, even more so when it rains, quickly changing to the mineral piersonite and turning from black to white. Additional water molecules are later added onto its crystal structure, transforming to the mineral galasite. Galasite then combines with calcite, dehydrating to form the mineral shortite. In contrast, gregarite, which is also black due to inclusions, can either transform to the polymorph calcite if it a calcium end member, or if sodium-rich combine with a water molecule to form thermonatrite, which has a distinctive bright white color. Thermonatrite then separates into sodium hydroxide and the mineral nacolite. Nacolite can then combine with the mineral gregarite and water to form trona. These chemical reactions all largely occur within 100 hours of natrocarbonatite emplacement, causing not only freshly erupted brown volcanic ash to turn white, but also for black lava flows to quickly turn white and decompose into a fine powder due to the varying densities each of the minerals it transformed into had. I hope that you enjoyed today's video, as I decided to analyze the geochemistry aspect of